Well, welcome back, class. Yesterday we reviewed we learned how to convert points that were in rectangular form. So in other words, points that are in the form of x, y into polar form, which would be in the form of r for radius and theta for the angle. So as a quick warm-up, we're going to review kind of that process of going from some of these Cartesian or rectangular points into polar. And I'm going to model the first one for you just as a quick review. If we take the point 4, 0, now I did say to visualize where it is on the rectangular graph. So if I was to plot this on a regular rectangular or Cartesian grid, I would plot it the x value of 4, y value of 0, this point would fall right here. Now, if we kind of overlay a polar grid to that, remember that we would end up having these circles moving out, we can see that the radius that we are at is going to be a radius of 4, so there's my r value. And then the angle that we are at, now this angle can actually be named multiple ways. We could call it 0, we could call it 360 degrees, we could call it 0 radians, or we could call it 2 pi radians. So when I'm naming this angle, I could technically use any of those. I could call it 4, 0 again. I could call it 4, 360. I could call it 4, 2 pi. Again, just some different options. So what I would like you guys to do is try B, C, and D on your own, and you're going to enter your answers to these three into Edpuzzle for me to be able to check and see if we're understanding that tomorrow. So now we know that if we are given the polar coordinates, if we are given the points a radius and an angle, we are able to convert those into rectangular coordinates, an x value and a y value, to be able to plot them on a coordinate grid. What we want to look at today is how we could go the opposite direction. So let's say that So let's say that we are given an x value and a y value, and we now wanted to convert these into polar coordinates, an r and a theta. How would we go about doing this? Well, if you kind of sketch it out, remember that an x value and a y value is going to represent a point somewhere in this Cartesian plane. And the horizontal distance to that point, that's going to be my x, and the vertical distance to that point, that's going to be my y. So if we notice that these, of course, form a nice little right angle here, we have this right triangle. Now, using that right triangle, we can use our Pythagorean theorem, x squared plus y squared equals, in this case, the radius squared, since the radius is going to be that diagonal distance. And therefore, if I wanted to solve for the radius, I could take the square root of that. Now keep in mind, your answer could either be a positive or a negative, and we would have the square root of x squared plus y squared. So our formulas for solving for the r value, the radius, would be to use the Pythagorean theorem. R squared equals x squared plus y squared, or you could say r equals positive or negative square root of x squared plus y squared. Now, the angle. Okay, again, if we wanted to solve for the value of this angle right here, and we do have a right triangle, then we can use some of our trig functions, SOHCAHTOA, to help us to be able to solve for that. Now, since we're given the x and the y values, using the x and the y values and this angle that I'm solving for, I'd be wanting to set up a tangent function. So my equation could say that the tangent of the angle that I'm looking for will equal the opposite, which was the y value, over the adjacent, which is the x value. And therefore, to solve for the angle, I'm just going to do the arctan, or inverse tangent, of y over x. So now I've got formulas for finding the angle. Again, some people just remember it as using the tangent function, y over x. Some people remember that to find the angle, we're going to have to do the arctan, or inverse tangent, of y over x. So now let's practice using these formulas. I do always recommend that you should always sketch a graph, visualize where the given point actually falls in the rectangular plane, and make sure that you're checking your answers at the end. Okay, so we're going to be converting our rectangular point, which is -3, -3, into a polar coordinate. We're going to be using radians, not degrees. And I want you to find two polar coordinates, one with a positive radius and one with a negative radius, that would match this point. So first, if we visualize it, the point -3, -3 is, of course, going to fall over here in quadrant 3. Okay, so kind of keep that in mind in terms of where it is. Now, this is our x, this is our y. So to find our r value, we're going to do either the positive or the negative square root of x squared plus y squared. If we plug in those values, -3 squared plus -3 squared, we're going to get, positive or negative, 9 plus 9, which is plus minus square root 18. As usual, simplify. The square root of 18 simplifies to 3 square root 2. So now we have a radius, and we have one that's both positive and negative. Okay, next thing we need is our angle. So to find our angle, we can set up a tangent equation. The tangent of theta equals y over x. Now it's the angle we're solving for, so we're going to do the inverse tangent of y over x. Both are -3. In other words, we're looking at the inverse tangent of 1. Okay, well, what angle has a tangent value of 1? Keep in mind there are two angles that have a tangent value of 1. Our angles could be, if you think back to your unit circle, in the first quadrant, we have an angle of pi over 4 that has a tangent value of 1. And in the third quadrant, we have an angle of 5 pi over 4 that also has a tangent value of +1. So now, how are we going to combine these together to represent this point that's going to fall ultimately in the third quadrant? So we do need to make sure that we are naming this point right here. And I did say I wanted to use a positive radius and a negative radius. So we'll start with the obvious. Since this point is in the third quadrant, I'm going to start with the angle that's in the third quadrant, and I'm going to use the positive radius, which means that I will be going in the direction of that angle. So I could call this 3 root 2 with an angle of 5 pi over 4. And this would send me to the third quadrant, to 5 pi over 4, and then I would go out 3 root 2. Now, my second possible angle would actually be directing myself to the directing myself to the first quadrant. So in other words, I'm going to point at the angle pi over 4, but then instead of actually going in that positive direction, I'm actually going to move backwards in the negative direction. So I'm going to move -3 root 2, and that actually puts me right back at that same third quadrant. So these are the two possible angles that would represent that point in the rectangular grid. Now, some points aren't going to be as nice of numbers as that last one. So once again, I am going to be asking you to identify two polar coordinates that would match this rectangular coordinate that's given. Our rectangular coordinate here is a -2.3 for x and a +0.1 for y. So if we visualize that, that point is going to be here in the second quadrant right away. And it does say we're going to have to do a little bit of rounding, so we're going to round all of our values to the nearest hundredth as necessary. So let's start with finding the radius. R equals plus minus the square root of x squared plus y squared. So plus minus the square root of -2.3 squared plus 0.1 squared. And again, I can use my calculator to evaluate this. So if we pull that over, clear this old stuff. Let's see, we've got -2.3 squared plus 0.1 squared. Then I'm going to take the square root of that answer, 5.3, and I'm going to round this to, it says the 100th, so that's actually still going to round it to about 2.30. Keep in mind, positive or negative. Okay, now to find our angle, we're going to set up our equation. The tangent of the angle is y over x. In other words, we will have to do inverse tangent of 0.1 over negative 2.3. And once again, we'll throw this into the calculator here. Now, when we do throw this into the calculator, don't forget to switch your mode into radians, depending on what you may have been doing the last time. So now we can do, let's clear this, we can do the inverse tangent of 0.1 divided by negative 2.3, and we get around negative 0.04. Okay, negative 0.04. Now, for the angle itself, we've got to think about where this negative angle actually falls. So that means since we have a negative angle, we're looking at something right down here, negative 0.04. And in this fourth quadrant, remember, our tangent function is going to be negative. Okay, don't forget the all students take classes. So if tangent is negative here in the fourth quadrant, tangent will also be negative up here in the second quadrant. So we need to place this same reference angle, 0.04, into the second quadrant as well. And now we need to name both of these angles. Okay, when we're naming the angles, remember, when we're naming the angle in the second quadrant, remember that we're naming it from the initial positive x-axis to that terminating side. So we are going to do pi minus that 0.4. And again, if you grab your calculator for that, we can do pi minus 0.04, and that's going to be an angle of about 3.10. So that's going to be my first possible angle. So at this point, it looks like we have two angle values that we can use. We have an angle value of 3.10 in the second quadrant, but we also have across from that an angle value of negative 0.04 in the fourth quadrant. Okay, so now combining all of this together, if we want to use a positive radius, let's start with that positive radius. So that means we're going to go out about 2.3 units. And we're going to be using our angle that actually falls in the second quadrant. Our angle is 3.10. So what this means is that we will go to an angle of 3.10 and we will go out 2.3 units. Our second way to name this angle would be to use our angle in the fourth quadrant, so the negative 0.04, but we're going to move backwards 2.3 units, so we're going to use the negative radius. And what that will do, I guess I didn't need a second parentheses there, what that will do is actually move us toward this angle. So we'd be kind of pointing in this direction, but then we would move back that 2.3 units, and we'd end up back in that second quadrant again. So these are two possible polar points for that angle, or for that rectangular coordinate. Okay, so what I would like you to do now is try the following four problems, E, F, and also A and B, on your own. Please pause the video, take your time. You are going to be giving two different answers for each of these. So I do want one answer that has a positive radius and an angle value. And then I want a second answer with a negative radius and an angle value. And we want that for all of these. For values, or for ones that fall on the unit circle, use exact values. If it's something that doesn't fall on the unit circle, then you will need to use decimals. If you're using decimals, we're going to say round to the hundredths. Okay, so take a few minutes, guys, pause the video, take some time to try these. We're going to have you enter your answers into the Ed puzzle, and that way we can check these when we come back to class. Oops. Okay, so let's pause and do a quick formula review of what we've learned so far. If we are solving for the x value and the y value, so in this case, we are going to be given a coordinate in a polar coordinate. We're going to be given a radius and a theta. To find the x value, we're going to multiply the radius times the cosine of the angle. And for the y value, we're going to multiply the radius times the sine of the angle. Now, if we are given an x and a y value, so a point in rectangular form, and we want to find the radius, we're going to use the Pythagorean theorem, and we're going to do plus minus the square root of x squared plus y squared to give us some possible radii to use. And then for our angle, we're going to be using our tangent formula, so we'll be doing arctan or inverse tan of y over x. Okay, so now what we're going to go is one more step. Using those four formulas from a moment ago, we're now going to take actual equations that are in rectangular form and convert them into polar form, because ultimately we're going to be learning how to graph these polar equations. Now, in order to do that, our goal is to make sure that, okay, if it's in rectangular form, remember, our equations are going to have x's and y's in them. We need to get rid of the x's and y's so that the only thing left in our equations are the r's and thetas, since that's our polar form. Okay, to simplify, you want to make sure that all of your r's and thetas do end up on the same side of the equation if they're not already. So if we look at the first example, some of these can be very simple. Our goal here is to get rid of the y, and in order to do that, we're going to have to replace it with something that involves a radius and a theta. Well, if you think back to that formula a moment ago, we know that y is equal to the r sine of theta, so we can just replace that. And this is our new equation. This is what the equation would look like in in polar form. Okay, now keep in mind, if I was to graph these two, these are both going to end up graphing the same thing. In this case, these are both going to end up graphing a horizontal line, and we're going to be looking at that next week. Okay, so that one was pretty straightforward. If we look at our second one, now we have an x and a y. So first thing, if we want to get rid of the x, again, think back to the equations from just a little bit ago. We can replace the x's and y's individually if we would like to, or, simplifying this a little bit, we do know that we could replace the entire quantity of x squared plus y squared with r squared. That was our Pythagorean equation, which allowed us to actually find the r value. So in this case, we could write this equation. We could even go one step farther and solve this equation and say r equals plus minus 2. Okay? Last one's going to have a little bit more involved in it. So in this one, we do have to replace the x and the y separately. Okay, for the x, we're going to replace that with our r cosine theta. For the y, we're going to replace that one with our sine theta. Now keep in mind that y is squared, so I do have to square that quantity here. And don't forget that we have a 3 out in front, and of course we have equals 2. Okay, now we do want to do a little bit of simplifying here. For example, right here we can square this quantity. That means that we have to square the r and we have to square the sine of theta. So that would give us r squared and sine squared theta. Then we can, since all of these are being multiplied together, we can multiply some of these. For example, I would say let's multiply the r and the r squared and combine that to say r cubed. So we could write 3 r cubed, so we've taken care of this, times cosine theta times sine squared theta equals 2. Now, as long as we have all of our r's and thetas on one side of the equation, then we know that this equation is simplified. It looks a little bit complex. One more thing that we could do is to divide both sides by 3 in order to kind of isolate the r and the thetas. So we could write it as r cubed cosine theta sine squared theta equals 2/3. Now, next week, one of the things that we're going to do is look at actually graphing some of these, and we are going to check out what these look like on Desmos. So we're going to actually come back to these three. I'm going to show you how to graph a polar equation on either Desmos or a graphing calculator. We hopefully already know how to graph rectangular equations on the calculators. So we'll graph these, and we'll be able to look at the comparison and see that they are, in fact, the same graph, even though the equations are written a little differently. Okay, so now we need to go backwards. We need to change now from polar form into rectangular form. So this time, you're going to be starting with an x and a y value. I'm sorry, I take that back. You're going to be starting with an r or a theta, and r and theta, and you're going to be trying to get rid of the r's and thetas and convert those into equations that are in the form of x and y's. Now, when we are converting from polar to rectangular, there are two strategies that we commonly use. The first strategy is to square both sides. And in the first example here, example A, that's the strategy that I'm going to use. Now, keep in mind, guys, that we're looking at what options do we have, right? We know that to be able to convert this into rectangular form, we need to get rid of the r in the equation and replace it with x's and y's. Now, we do have an equation for r equals, but that equation involves a complicated square root, a plus minus, just a lot going on. So the alternative method here is to say if we squared both sides of the equation and rewrote it as r squared equals 25, now when we replace the r squared, we can now replace the r squared with our equation that says x squared plus y squared, remember that was that Pythagorean theorem, equals 25. Okay, once we get x and y on the same side of the equation, we're kind of done with simplifying that one. Now, there are going to be times where we will have to do completing the square, so I'm going to be showing you an example of that. But for this one, here is our final answer in rectangular form. Now, we are again going to be able to talk a little bit about what are these equations. Remember that the equation r equals 5 is the same thing then as this equation x squared plus y squared equals 25. So when we come back and graph these, we should be able to see that even though one is in a rectangular grid and one is in a polar grid, they should be showing us the same picture. Okay. Now, example B, we could do the same strategy on example B. We could square both sides, for example, square the r, but that would mean that on this side, we're going to have to square that whole binomial. That's going to get us a pretty complex trinomial. That seems like that's a little bit more work than we want. So I'm going to recommend on this one that we actually just multiply both sides by r. It gives us the same process by multiplying by r on this side and by multiplying by r on this side. We're still going to get that r squared. Now, on the other side, we are going to distribute that radius, that r. So now we have r cosine theta plus 2r. And now we can go back and do some replacing. So once again, I will replace the r squared with x squared plus y squared. I'm going to replace the r cosine theta with just x plus 2, and now the r. Unfortunately, the only thing we can replace the r with is that square root of x squared plus y squared. So this one is a bit of a more complex equation, and with the complexity of this one, we are not going to simplify it anymore, so we're going to leave it at this. Okay, let's look at another example of changing from, again, polar form to rectangular. So once again, we need to do some rewriting until this equation is in terms of x's and y's. Now, in this equation, we do have this secant, and we don't have anything written in terms of our inverse functions. We use our sines and cosines and even tangents. So the first thing I'm going to do is rewrite this as 1 over cosine, which means that this whole left side of the equation can be rewritten as r over cosine theta equals 6. Now, looking at this equation, you can do a couple of different things. I'm going to look at it as cross-multiplying. So if I write 6 over 1, I can multiply the r and the 1 together to get r equals, and then this would be 6 cosine theta on the other side. Now, like we did with the last problem, I think our best strategy here would be to multiply both sides of the equation by r in order to get that r squared. Okay, so we can multiply by r, and on this side we're going to multiply by the r as well. That means that I now have r squared equals, now keep in mind all three of these are being multiplied, so you can write them in different orders, you can move things around. I'm going to do 6r cosine theta. Now, replacing, because we are trying to get rid of anything with r and theta and replace it with x's and y's. So I'm going to take out the r squared and replace that with x squared plus y squared. I'm going to take out the r cosine theta and replace that with x. So I have 6x. This is an example of one where we need to get the x's and y's on the same side, and in this case, we are going to have to do completing the square. Okay, so it's been a little while since we've done completing the square. This will be a nice little review. First step is I'm going to subtract the 6x to move it to the other side of the equation. I want to group together my x terms, so x squared minus 6x, and I'm going to leave a blank space. Then, of course, I have my y terms, where I only have one of that, and now I have equals 0 on the other side. Okay, so now completing the square. We're going to take the x terms here, and we're going to do that completing the square process, which means we're trying to create a perfect square trinomial. To create that perfect square trinomial, we're going to take that middle term, that -6. We take half of that, so -6 over 2, and we square that value. That means that I'm adding in a 9 to complete my square. Now remember, if we add something to one side of the equation, such as that 9, we also need to add that to the other side of the equation. So now my equation says, on the right-hand side, equals 9. Now back to the left-hand side, remember that I have created a perfect square trinomial. So I can factor this perfect square trinomial into x minus 3 squared. I can bring down my plus y squared, and it equals 9. This is my final equation in rectangular form. And once again, we're going to be looking next week at how these two equations are actually identical and are going to be giving us the same graph, just on two different grids. So I would like you to try this last example on your own. I will give you a couple of hints since this is the first time we're learning it. Just like the last problem, I would recommend that you multiply both sides, multiply by r on both sides. And then I do need you to make sure that when you are getting your x's and y's on the same side, that you are also completing the square. And what we're going to ask is that you enter your final answer onto the Ed puzzle so we can see how everybody has done with this last problem.